Faster, secure software development with continuous deployment. The organizers of PHDays actually called me up a couple months ago and asked to, hey Nick, why don't you give a talk on something? I go, hey, I've been doing continuous deployment for a while. They go, yes, that's what we want you to talk about. Interestingly enough, Microsoft called me up a few days later, and they also wanted a talk on continuous development, continuous delivery. What's interesting is the Microsoft conference and this conference could not be different audiences, but yet both are very interested in this. There's a lot of interest. Almost everywhere I go, people are like, Nick, how can we deploy code faster? How can we deploy it securely? And here are some of my secrets. So, these slides are online. If I'm talking too fast, or if you want more information, please go here. And just a little bit about me. So I've been sort of in software development for about 20 years now, and mostly focusing on high growth startups, which have enormous needs to get code out quickly. But last few years I've been getting back into security, Black Hat, DEF CON, OAuth talks, personal website is here. But you guys may know me as the author of libinjection, which is sort of a very interesting SQLi sort of detector. And right now, Vladimir in another room is cracking it wide open. I'm disappointed I can't see his talk. Feel free to check it out. If you find a bypass, please let me know. It's a work in progress. So anyway, I'm here partially because I work at a company called IPONWeb. They are based in Moscow, actually, and they build extremely high volume ad exchanges, online advertising. And online advertising might be ho-hum, but it's really enormous volume and scale, billions and billions of transactions, per day. Online advertising really is the first form of micropayment that's successful. So we have enormous needs too, and absolutely we are hiring, and we're in Moscow. We have 2 offices as well as some other places. I currently live in Tokyo. All right, so fixing security by fixing development using continuous deployment. That's a fairly bold statement. And I'll go even further and just basically say that for web applications, which I'm going to talk mostly about today, but certainly will apply to your industry too, our release-based software development lifecycle is, I wouldn't call it quite obsolete, but it's based on a life before the internet, right? And because of that, it's particularly harmful for security in organizations. Okay, so fixing security, fixing development, what actually needs fixing, okay? So I don't know if you caught the latest White Hat security report, State of Web Security. Hey, SQLi dropped from number 8 most seen vulnerability to number 14. And then if you keep reading a bit further, it goes, oh, this means when people call us up to test their website, we see SQL injection in only 7% of their websites. 7% is enormous, and this is the 14th most popular vulnerability. 14th most popular vulnerability. What does the number 1 vulnerability look like? And here's the worst part is, so they scan sites, they find a SQL injection or some other problem, average time to fix, 196 days. Like, that's just embarrassing. It's embarrassing for security, it's embarrassing for development, it's embarrassing for any organization you work at. Can you imagine working at a company where you're in charge of security and it takes you 196 days to fix this? I mean, you might as well just go home. Like, why bother, right? Actually, so even better is Veracode actually says maybe 32% of all websites have a SQLi vulnerability. So maybe not 7%. Anyway, it's a disaster, in other words. All right? Even worse, from the White Hat report, the number 1 reason to fix or not fix security problems is compliance, which has got to be the most boring reason in the world to do anything. If your job is really not fixing things because of compliance, again, go home, quit your job. Actually, the market's super hot. Just go find another job. There's no reason to put up with this nonsense. It's not like being professional. It's not like being, good at QA, protecting our customers. It's compliance, which is pretty sad. Okay, the other thing, this huge disconnect is security products happen to be #1 in security bugs, which is sort of a fascinating thing too. 74% fail rate when Veracode gives incoming application from security company comes in, 74% they pass the first time. I'm sorry, 74% they fail the first time. That's pretty bad. Obviously a big disconnect between security and development. And development is, hey, these bugs don't happen magically. They come from development, right? So what are we going to do here? Very interesting. I just spoke after Tao Wen's talk, which I hope you caught, so it's fascinating. This came out in Bloomberg, and it was, sort of the typical American news article on China cyber spies stealing everything. Actually, in this case, it was Chinese, and basically, this company was so wide open, Chinese and Russian hackers were stepping on each other to like steal stuff. It's quite an impressive document. But if you read this, there are so many things wrong with this tiny statement. This company, which I never heard of before, makes like satellites and global communication and global surveillance type stuff and missiles and God knows what else. This guy just has like no idea what's going on. Just at the end, he goes, you just reach a point where you just give up. And you read the article, the Chinese and Russian hackers did not give up. They just kept pilfering information for another 2 years while this was going on. It's quite an incredible article, so feel free to download it afterwards. And again, Veracode predicts CISO turnover, big increase in that, which basically means burnout, which at some point, these are jobs you're going to have. Burnout and getting washed out early is not so great. But here's the weird part. SQL injection, I don't know if you're on defense or offense, but the fix for these things is really small. It's like fixing a SQLi, fixing a cross-site scripting, fixing a buffer overflow, really tiny, a couple lines of code, maximum. If you're fixing like, authentication systems and things like that, yeah, it's a little more complicated. But most security vulnerabilities are really tiny, yet we can't seem to get them fixed. So what happened here? How did we get here? And this is something I made up. I call it the software product model of how code gets out to production. And it's pretty straightforward. Product managers write code, engineers write code, QA guys test code, release engineers package stuff, and the ops guys run it. And maybe somewhere in there, security does something. It doesn't really fit in, and it's very sort of linear, right? So if you look at that model, this was designed for when the cost of distributing software was high. If you have to actually get a physical CD or DVD in the store, it's a very expensive process, right? So you want to upload as much quality and security as possible early in the release cycle. Other things, embedded hardware, exotic systems, defense, medical, things that do not change often. Again, software product model. Operating systems, really painful to upgrade. If you're like Microsoft or Apple, a OS release is really expensive. And we've all been trained to do it this way, right? Homework is the one-time deploy. You have to give it to your teacher, and that's it. There's no second guessing. It has to be perfect, has to be right. There's no incremental improvement. That's it. So we've all been trained that when code goes to production, it needs to be perfect. Okay. And this is sort of a typical software lifecycle where you get some specs in the middle. There's this huge ramp up of development, and then it sort of tapers down, and then it goes out into production. If this doesn't make sense, just think of your homework. You get the homework assignment, huge this, and then it tapers off, and the TA or professor grades it. And this is what the production environment looks like. There's it sort of doesn't do anything, and there's this huge spike of change for a new feature or a new release, and it's sort of quiet, maybe a little bumps in the road, and then another huge release. And if you worked at sort of many financial institutions, this is how they work, right? Huge changes in production environment irregularly. Okay, so wow, I was going to say 10 years ago, 13 years ago, How are web apps made, right? We followed the software product model. It's all we knew. And building web applications was really expensive. Linux wasn't really prime time. PCs were very expensive. Data centers expensive. All this stuff very complicated. And you need a lot of engineering just to keep things running at all. And just as sort of a side note, year 2000, I did some research. It looks like the CERT CVE sort of started right around this time. So right as the internet's beginning to start, you're starting to see some problems occur. Okay, so these are actual things over the last 10 years I've encountered from my boss, CTO, whoever. And we had all these problems and we're doing this big release. There's a spelling error. Nope, no changes. That code is locked down. I've seen too many times developers do a cut and paste error. No way, spelling error is not going out to production. That's weird. Like, it's just a weird model. Like, if you cannot fix spelling errors in code because you're afraid of breaking things. So that's another true story. Actually, the next job I had asked my boss, like, so how do you prioritize the spelling error problem? And he goes, you do an iteration where all you do is tiny changes. And then QA has to QA the entire site, and then things go out. And maybe that happens like once a year. Just so much crap piles up, you just do this release just to fix things. Again, that doesn't seem like a really good model either. So if we go to today, I've not actually read this book. I don't know if it's good or bad, but I like the title. There's almost no barrier to entry. If you're doing a web app, I mean, we could do a lab right here where we go from DNS, purchasing a domain, to firing up a website on Amazon, probably in about 10 minutes, right? Zero barrier to entry. And commodity hardware and programming now, not that hard, as the book demonstrates. The other thing too is most books don't really talk about security, so most people doing it are actually going to immediately learn how to do things the wrong way, right? Okay, so 2013, what's the cost of software distribution? It's free. I still do C and C++ programming. Sometimes the compiles can take long, but for most people, there's no cost. You're changing a few megabytes of code. There's no compile step. You're pushing things over fiber, 1 to 10 gigabit links. It's free. Cost of distribution for a web app is free. But unlike the software product model, failure is really different, right? What happens is web apps are data-driven. It's a little different than Microsoft Word was 10 years ago. There's data coming in from APIs, from users, things are getting stored in a database. You just don't know what's going to happen. So what's interesting is you have this database, this collection of data that's been sitting around for a long time. This means data in the past that had a bug, a problem, can actually cause bugs in the future. You push out a release, there might be old data in your database that works differently with your code. So you can't really predict what's going to happen. I've seen this over and over again. It's either operational load or data coming in from both sides. You don't know what's going to happen. Okay, so I don't know about you, but I've been doing software development for a long time, and I'm sure some of you have lived through this. A bad release goes out, right? Enormous pain in the ass, very disruptive. The rollback is painful. Basically, the entire company shuts down, certainly development and QA and release and operations. A rollback of everything, you have to figure out what actually broke, because it's not quite clear. You have this enormous production database. You have code changes from 50 different authors, what actually broke. So meanwhile, new code's piling up, and you have this cycle of like these huge crests of changes in production. Okay, so back to more what we're talking about here. Anytime you have a long period of when code has been written to when it goes into production, there's this weird disconnect that happens. Might be weeks, months. I certainly know a number of banks that spend, they do 3 or 6 month release cycles. So imagine if you're the engineer building something, day one, some new feature, and your code doesn't get released out for 6 months. It's outrageous, right? So when you go in and go, hey, by the way, your code has a bug in it, has a security problem, they could care less most of the time. Like, 'cause they don't even remember writing it. Huge disconnect. And this is sort of the source of many problems. I mean, okay, so here's sort of the hypothesis I have for certainly web apps and certainly for many more apps. If you're doing mobile development, same thing. You can't actually test every possible scenario anymore. Can't do it. Your development environment is not the same as production, right? There's subtle differences, which means there's almost no amount of QA or security testing you can do to prove that this release won't be a disaster, right? And you might not even know it's a disaster for 6 months from now. So, sort of the big news is here, no matter what project you're working on, no matter how much QA you got, there are bugs in your live application right now, and there's security problems in your application right now running, just waiting to be exploited. That's a really important statement we're going to come back to in a few minutes. So again, all this again, easy to write code, long release cycles, security coming in either right before a release goes out or afterwards. It's an out-of-band process. Really no one cares. You guys are responsible for something that's going to break, and no one actually really cares about it until it occurs. That's a real problem. Okay, so if I go back into sort of operations research, this basically says the mean time between failures, security problem, is way less than infinite. Like basically what this means, shit happens. You will experience a security problem, and there's nothing you can really do about it. All the QA in the world, all the software products in the world will not prevent this, right? So, I sort of gave away it already. What's the answer? Going slower? How many people have you went to your boss and said, hey, we need to slow down the release cycle? You'll just get fired. Like, that's just not the job anymore. More steps and more process. In other words, slower, right? And what happens is, as you keep doing these really long releases and you keep having problems with them, what you try and do is, wow, that was really painful. We should do less of them. It's this downward spiral of making a release cycle longer and longer and longer. And what else? What other things, suggestions? Like you buy more products, assuming there's a budget. I don't know, these products, no offense to the vendors, but it's an endless upgrade cycle there too. Okay. So finally, I talked about why we're here, continuous deployment. Deployment. Also sometimes known as continuous delivery. And I've changed this sort of statement a few times. I'm going to read it, make sure I get it right. A system of software production characterized by numerous small changes to the production environment initiated by the author of the change. You change it, you push it to production. Frequently. Okay. When you do this well, the amount of change, your production environment is always changing a little bit. New features are controlled by you flipping a switch, not pushing out huge chunks of code. So it's a little different way of programming where you switch on features instead of pushing out features. And we'll talk about that in just a moment. Okay, so writing software. And here's the other big shift, I think, that's happened in the last 10 years that we're not quite dealing with. And I'm fighting this now at my current job. Software developers actually think their job is writing software. Well, okay, that's certainly part of the job. This isn't Microsoft Word anymore. It's not a desktop app anymore. This is, and because they think their job is purely writing software, they really want, it's just like homework all over again. Oh, no one can see my code, it's not perfect yet. It's not quite ready for anyone to see yet. I can't show you, it's going to be on some branch. It's completely invisible to you, the security person. I mean, maybe it is on a branch, and if you spent the time, you could pull it out, but reality is it's a pain in the ass, you're not doing it, right? Anyway, it's invisible code that no one knows what's happening until it's actually on production. So nowadays, the software developer's job is actually writing running code that actually works well. And this is sort of a subtle change, and it's a definitely different way of thinking. And a lot of companies that I've worked with in the past have really struggled to turn software engineers into people who are interested in their code, running. It's not just the homework assignment, you're done. What does running software look like? So they've done all these little tricks. And most of these companies you've heard of. I actually just heard this one a few weeks ago. Writing code is hard. If you cannot deploy it, it doesn't matter. It doesn't matter how smart or genius you are. If it cannot go to production, it doesn't matter. It just doesn't exist. Two types of code. Code in production, code not in production, right? Facebook, move fast and break things. This was great. I was looking for this poster, and this one on somewhere, I don't know if you can see it. It says, move fast and break things, except for data, don't corrupt data, and don't break the push system, which is their name for deployment. Break anything else. Bring down the entire site. It's okay. We can bring it back up. Just don't break the deployment system. And if you read carefully, don't break hearts, and breakdancing is okay. So, my alma mater, Etsy in New York, these t-shirts, just ship the code. Just stop obsessing on perfect, get it out. Which seems a little bit at odds with security, but we'll come to that in a sec. Okay. So really, the source of all these security problems, in most cases, is really, developers. Code has problems in it. It doesn't mean it's their fault, but they are certainly the, originators of these problems. And so, if we cannot get developers to care about what their code does in production, I don't think we can actually solve security stuff. It's just, as big as this conference is, it's what, 1/100th of the number of people who do software development in Moscow? Probably. 1/1000th? Last few jobs I've had, I've been brought in to do security. For the first year, I actually didn't work on security. I worked on operations and development to fix that first, because then you can really do some interesting stuff. Okay, so how does this work? Let's see, time check here, great. Developers push out their own code. Like, how would this work? How is this not a complete security disaster? And I'll tell you why. When you've come from a background where it's sort of waterfalled and there's like these very distinct steps, it sounds a little crazy to do this. Whoa, excuse me here. There we go. What if you had a big button, the deploy button, and you hit it and code flowed from trunk, head to production? What if you just did that? Just break all your processes and just say, hey, I'm just going to make this button. And obviously it's in source control and it's logged and all this other good stuff. That's it. That didn't format very well. What's interesting is when you actually do this, and we've done this with new hires, all right, go push your code out now. Oh, what? Isn't someone going to do that for me? Or I don't want to break the site. This is great. This is a new hire I had like about a year ago, and the first day we make them do an HTML change on like the about page, like, hi, my name's Nick, I'm a new employee. And I go, okay, go push out the change. Like, oh, I might break the site. With an HTML change? I mean, if it did, that'd be kind of interesting. But it's like, it shows how little actually engineers know about what the actual process is, right? It's pretty interesting. Don't want to break the site. Okay, so I'm just going to walk through real quick sort of the progression, and this will be a little fast, but the end result is if you sort of work with VP of engineering, whoever you are, and say, hey, we're going to make it so developers can push their own code out, the developers will actually build tools to help them. No one likes breaking the site, so they will build tools around it. And this is one example of how it all works. So first push, you've just ripped apart your whole QA release cycle, and you got the button. Someone's going to slap it, and they probably don't even know what's actually going out to production. Someone's just going to push it. And what's going to happen is, first time you do this, yes, your site is going to explode in a million pieces. And actually, even worse is that developer won't know about it. Someone else will have to tell them, oh, by the way, whatever you did just took down the site. Oh, that's not good. Okay? So maybe what we need to do is make sure the developers actually know what the site looks like, right? What does a healthy running site look like? Now, I'm sure you guys all have operations departments, and they all have all these fancy graphs. Expose those to developers. I've been at a number of places where it's like, oh no, it's operational data. Developers can't see that. Why? Who's speaking? Okay. This graph I just did, sort of jumped ahead for security stuff. You can see a huge spike in login failures in the middle of the night. We're going to see how you can get these graphs in a minute. Anyway, get those operational graphs to developers. So when they push that button, they can see if the site goes down or not. Okay? First push. Site might explode, but now the developer knows it and can roll back on his own. I guess there's another button that says roll back. Okay? 4, the developer actually goes, oh, hey, what the hell is actually going out to production that's killing everything? I got my feature. What else is going out? So instead of pushing out a million things, let's just push out a really tiny amount of code, maybe just the bug fix I'm working on, whatever it is, right? Just do that little thing. And you know what? It's probably going to work. A little change. If it doesn't, you know exactly what broke. As opposed to the big bang release, you have no idea what actually broke. You have to roll the whole thing back and waste a week figuring it out. And this is the secret. Small changes that anyone in the organization can understand. Okay, so how do you do bigger things? And this topic is really like another hour, which we don't have. You're doing a major new feature, major new change. It probably has a bunch of source files, bunch of things going on. Push all that code out, which isn't actually lit up, it isn't actually working yet, but isn't actually being run in the production environment. So you have a new feature.php, push that out. Nothing's linking to it, it won't get executed. I call it a dark push, it's like invisible. But yet, it's actually in production. That's a very powerful difference than it hiding on a branch, right? You can see it, you know where to find it. Very useful. Again, it's not actually running. It's just in production, but not linked. Okay. So let's say you got all these supporting files out, and it's time to turn on your feature, right? The old way is push out all the code, the entire world gets all the feature at once. Most large sites do not do this anymore. It's too dangerous. It's just too complicated. By large sites, I mean, Google, Facebook, Twitter. I'm 100% positive Yandex and almost every other large company you work with pushes things out incrementally. They ramp up. So if the user ID, mod 20, 5% of your users get it. See if there's a problem. Maybe just turn it on to internal employees only. That's fantastic for security because now you can do a test of exactly the code that's in production. Web stuff's always different. SSL certs are different, cookie domains are different, all those little details are different in dev. Certainly good to practice on, but nothing's quite like production. So if you can get that code out, even if the feature isn't working well yet, you can start engaging the developer on how it actually works. That's really important. Okay. Application level graphs. So that's actually the graph I showed before with sort of the login stuff. And if you remember anything today, remember the word statsd. What's fantastic about statsd is you can instrument code, maybe a line, put it in the application, and you'll get graphs like that login graph. Let's go back to that. That's important. There we go. Okay. So this, and there's URLs in my slide too. Remember this, because how did I make this? I added the stuff I did at Etsy, one line of code in my application. Every time there's a login failure, it spits out a little UDP packet. UDP packet is magic because it can't break your application. It's risk-free inside the application. There's no I/O exception. Maybe it might not get to its destination, but the application you put it in will not break. So you can start doing some really interesting things by instrumenting your application code, and it will send these little UDP packets to statsd, which aggregates them, collects them, and then it writes it to something called Graphite, and you can make all these cool graphs. This gives you visibility into what the application's doing, and it makes security visible to your organization. And that is, nothing's more important. So statsd, Graphite, I'm going to give a talk on that, I know, maybe next year. Okay, let's go back to the track here. Application level graphs. Same thing with application level graphs is make the same thing for logging. Make it easy for you to add logs, make it easy for developers to add logs that get pulled back somewhere where they can see them themselves. Where I'm at right now, it's funny because they don't have this, we're working on it. And what happens is, someone in ops goes, hey, the application made an error. Okay, what's the error? Oh, okay, let me cut and paste it from the log the developer can't see and send it to them. It's like this round trip of slow. Let the developer see the application logs. Why not? They're the one who made the problem. Get that data to the consumer. Okay? Now again, great, I have the deploy button. How do you prevent everyone not just punching it simultaneously? And I don't know if you've heard this phrase, if there weren't seatbelts, everyone would drive a lot safer, right? Fear of death causes people to drive a lot slower, right? You'll be surprised if you implement this that people will self-organize into making a queue. It's about respect between the developers. No one wants to break the site. IRC-like tools, Hangout, Skype, people can coordinate themselves on how to do releases. When someone's done, you hand it off to someone else who can do a release. It actually works. I'm hoping to release some tools on that later. Okay. Again, mentioned this already. Exposing logs to developers. Add staging steps so you can actually see what's going on. Start working on how can you eliminate errors quickly. This is also like software development stuff. I will show you why that's really important. And mistakes will happen. Certainly the first time you start implementing this, someone's going to freak out. But again, how can you make the environment, whatever caused the problem, how can you make the environment better so it doesn't happen again? Mistakes happen all the time. People don't change. You can change the environment. Better tooling, all sorts of other stuff, static analysis, all this stuff to help the developer do a better job. Okay, so great. Anyone can push code anytime? What about that guy who wakes up in the middle of the night and pushes code? Well, this actually happened in my last job. After waking up the entire operations team, who he probably didn't even know was on call, because he's a developer, he doesn't think about these things. The phone calls to him like, hey, what'd you just do? We saw you push code. That developer now knows not to do that. Or if he's going to do it, he's going to call operations first to make sure it's okay. Now, your company might have your own policies on this anyway, but again, once you start giving responsibility to people and they're aware of consequences, you will see better behavior actually. Okay. Code reviews. So I don't know what your software development life cycle is. Almost nothing I've said changes that. Want to do code reviews? Absolutely do code reviews. They're easier now. They're smaller. They happen every day. When you tell your boss, whoever's doing your code review, hey, I got done with my new feature, can you do a code review? And it's 3,000 lines of code, and someone has to take an entire week off to do a code review. Guess what? They're not doing a good job. No one wants that. if it becomes a regular cycle of like, hey, why don't we spend 10 minutes every day, review what we're going to push out, much different behavior. And they're small, they're not in some branch hidden, they're in mainline, easy to see, easy to do code review. What about security reviews? Yes, please do them. Nothing here changes sort of architecture design. You still have to do all that. This is pushing out the code that implements it. So yeah, absolutely. Agile methods, very popular. Really, they sort of focus on the spec to what's being coded. They don't really focus on the code to production. So they're very complementary. Right? So you can still do everything you're doing. And this is a comment I get all the time. What about customer service? Don't they freak out when the site keeps changing all the time? Well, most of the time, customer service doesn't freak out when bugs are fixed. So that's fine. New features, code deployment is different than features. It's little stuff, most of it doesn't do anything. You light up features in a completely different way. And you certainly talk with product and customer service to manage that part. Oh, about compliance and PCI. Okay, so we actually have the same system in a PCI environment. I guess, yeah, it applies here too, right? It's a mechanism, not a policy. Meaning, being able to push code out quickly doesn't mean it doesn't go through everything. It doesn't go through all the compliance stuff, right? So you can still do it. You might have some different rules on what that deploy button looks like, but it absolutely, there's nothing in the regulation that says you can't do this. I can talk more about that afterwards if you want. Okay, let's go back to security. Okay, so let's say you implemented all this. Here's sort of the big deal here. Those security bugs, and my guess is you probably spend, depending on what type of organization you're in, a lot of time managing just the catalog of things that need fixing. SEIM, all this other stuff. You know, those can go out now. Why not fix those low priority bugs? Why not just get rid of them? You have something? Get them out. So the beauty is, if you're under attack, if you find some problem in the code, there's no reason why you just can't get that code out immediately. You know this because it happens every day. Security is part of the release cycle. Hey, you need to patch cross-site scripting or SQLi thing? Great, you can push it out. Or you can find a developer and you guys can push it out together. It's a completely different game now. It changes the feedback cycle. Okay, and again, you know, that engineer who actually didn't know if the HTML change is going to break the site, they actually know now. They know the second half of their code. It's like they gave birth to the code. Now they got to watch it grow up, and it's really amazing how security is a great topic, right? We're all here because we think it's pretty cool. Most developers aren't that interested in it because they're not incentivized to actually care about it. But once you make it easy for them, you'd be amazed at how many people in your engineering organization become interested in security. And that is like this amplification effect you cannot beat. There's always people who won't get it or whatever, that's fine. But you're going to find people in your development cycle that are really interested who will be helping you do your job. So again, sort of the new security math, and actually I was at Microsoft, the new Microsoft conference just a couple weeks ago. The new CSO at Adobe, who we all know has a long history of sort of problems, really, instead of constantly trying to push the time between security problems to infinity, just more firewalls, more stuff, we just won't have a problem. What you really should be working on is how fast can you detect problems? How fast can you resolve problems? Because if you believe some of what I said, you will have problems no matter what you do. Production is completely different. There's no amount of QA you can do. There's no amount of security testing you can do. So how can you focus on mean time to detect and mean time to repair? Once you clear out all this backlog of little stupid stuff that's been sort of collecting, you can really start focusing on how can I detect and repair stuff? And that changes things quite a bit. All the stuff that we just talked about that help developers do their job, now you can use all that stuff to do your job. right? We'll talk about this in a sec here. So again, I sort of mentioned this already. We put in application level logging so developers can see if they break stuff. PHP is really noisy. Most developers don't know it. You can now use this centralized logging for your own knowledge. You can start instrumenting stuff. Hey, what is the average size of a password? Okay, just start logging some of that stuff and do some math on it. Maybe not the best example, but you get the idea, right? Or the other time, this happened to me frequently. You're under attack by someone, denial of service, whatever. You need to upgrade the app really quickly so you can see what's going on, right? You can do this. It's not a big deal anymore. Just, hey, we're going to add some logging. 10 minutes later, you're in business, right? Graphing. Start graphing all this stuff. One reason security is sort of a problem is it's invisible to most people. And invisible things aren't valued, right? So making what you do visible is really important, right? So start making graphs of this stuff. You can use libinjection, actually, for SQLi. Just start graphing all this stuff, because you will see, instead of security being this breach, not breach type of scenario, which I think surprises everyone hates it. Like, hey, I got a dashboard. And you know what? We're probably, during a day, get like 2,000 SQLi probes on our website. Oh, let me tell you, I've shown these graphs a few times to people higher up in engineering or business. Pretty interesting. Pretty interesting to them too when you do geo IP location on that stuff and you show where they're coming from. Really changes executives and other engineers' opinion on security. Instead of a binary thing, it's a living thing. Stuff's happening all the time. You just don't know about it. Static analysis. Start with this regular static analysis. Just finds bugs. Certainly in C and C+ code, static analysis is security analysis. Buffer overruns, all that other stuff. PHP, same thing. Every language has got one. Work with the QA group. Post-commit checks. This is great. Code's going out all the time. Well, certainly alert on when interesting things are happening, right? Anytime the auth and login stuff, alert immediately. Right when things get committed. Why is a developer using crypto? Maybe I should go talk to them, find out what they're doing. Find out right away as soon as that stuff hits the commit log, right? This allows you to engage the developer at the start of the cycle. That's a big difference. Faster is better. Again, same thing. I'm going to speed up just a bit here. New roles, less silos. Once you clear out the backlog of silly stuff, you can start actually being sort of a consultancy in your organization. Instead of just whack-a-mole, you'll believe it, people will come to you. It's like, hey, I'm trying to do this feature. I don't quite know how this works. And you can help them. Totally different role than you might have now. So, last 2 minutes here. What should we do? Okay. Whatever organization you have, work at doing a 50%, make it the goal for the year. However long it takes in terms of people, time, resources, work on doing a 50% reduction in time. Whatever that means. This is an easy sell because the time spent deploying code is kind of dead time. It doesn't really add any value, right? It's dead time. So once you start sort of squeezing the deployment cycle, everything else is going to follow from it. Setting these goals will allow developers to become creative to fix this stuff. So strive for the fastest deployment mechanism possible. At Etsy, my previous company, we really did 60 deploys a day, each with 3 to 5 authors each. It's a website, didn't have much commerce in it, no problem. Current gig, we don't deploy more than 3 times a week because our customers can't absorb the change that fast. So it's whatever it means to you. Our deploy cycle is maybe about 2 hours. I think that's still way too long, right? In other contexts, again, how many people regularly upgrade their router? You don't because it's too painful, right? That's the security problem. All these things, how fast can you deploy patches to the desktop? Once you start making goals on making the pain point smaller, you're going to find a huge change in how business is done for you, much better. software product will skip. Silicon. Now, what's interesting, I gave this talk, similar talk, maybe 6 months ago. Some guy went up to me and goes, hey, do you work with silicon at all, like ASICs and stuff like that? Like, no, it's like, oh, we do this. Like, well, how does that work? It's like, oh, we learned a long time ago, big changes don't work. So every change that goes out is really tiny and fully tested. So other people that have like enormous deployment costs know this trick. Oh yeah, one more thing. Oh, just about out of time too, good. Your attackers use continuous deployment. You think running a botnet of 20 million machines is easy? No, it's not. And let me tell you, I know firsthand from all sorts of forensic investigators that while they're trying to close holes, the attackers are actively morphing code against them, recompiling, redeploying to whatever they're doing. So your attackers know this already. They can update their army or their 0 days or whatever in faster than you can, right? So you got to get on the program here. So continuous deployment, start with a 50% reduction in time this year. Work on building that deploy button. Thank you very much. Slides are online.